We have a sample. And so by the word sample, I mean an actual measured amount of something that you can see or touch or feel or smell, all those things. So 0.50 grams of carbon dioxide. Okay. So the other way we can say carbon dioxide, which is much simpler than writing out the words carbon dioxide, is CO2. And then it's state of matter. And so what we're going to work on is we're going to work on looking at both the chemical and putting it together with why is it in a certain state of matter. So I want you to look at the chemical, and I want you to write down anything you can think about that you know about the atoms that are in it, the substance it is, anything at all. Look at the periodic table. Any what you think is a minor piece of information is not minor, because every single tiny thing is what we're talking about. And then separately, what does it mean for a substance to be a gas? Why is it a gas? Like, so just, and it can be just the most basic idea you can think of as to why it's a gas. So just jot down, because these are in your notes. These are things that I want you to think about. And then I'll give you a few minutes just to write down some just real quick facts about CO2 and gas. And then we're going to talk about it. And then hopefully we'll have time for you to look at one of the samples with someone else. And I'm going to have you do the same thing. So but there's covalent bonds. Why are there covalent bonds?
It's between
two nonmetals. Okay, so when you look at a formula, you look at the identity of the elements involved. If you have nonmetal and another nonmetal atom, then what's going to connect them are covalent bonds. So to have a covalent bond, you have to have at least two atoms. They're either going to be two nonmetals or two metalloids or a nonmetal and a metalloid. The closer they are on the chart, the more likely they are to share electrons. And if the sharing takes place with the elements over to the right, it's covalent. If it takes place from metals, it's called metallic. Okay. So non-metal, non-metal. What is the identity? And so identity, I'm talking about whether things are metals, non-metals, and metalloids. So the type of elements, that is the non-metal, non-metal. State of matter is due to the entire substance and then what holds it together. So you wouldn't put type as in something's a gas, because that's not a type. That's a state of matter. You may write anything else down? Why is it, what does it mean for something to be a gas? The most basic reason why something's a gas. Why is water not a gas? It's not hot enough. And so in order for you to turn water into a gas, you have to raise the temperature above its boiling point. So why is something a gas? Because the temperature that the sample is at is above its boiling point. The most basic answer to why something is in whatever state of matter is because the temperature is above its melting point or below its melting point or above its freezing point, or those basic physical properties of a substance, which are tied to what it's composed of. So the reason something is a gas is because the temperature is above its boiling point. That's the most basic answer. That's not the molecular answer, but that's the most basic answer. Things are gases because they don't want to be together. They're not stuck together. There's no attraction between particles. So they're just going to bounce off each other. Okay, so we got non-metal, non-metal. How many carbon non-metal atoms are there? Just one. We have one atom of carbon, and how many atoms of oxygen? 2 atoms of oxygen. And that is literally how many atoms. This is not a ratio. So there is 1 carbon and 2 oxygens. It's not a 1-to-2 ratio. It is a here is 1, here is 2. That's all there is. So because of that, toward the end of Chem 151, we would draw this. So does anybody remember what you have to think about in order to correctly draw something that has covalent bonds? Electrons. We're going to draw valence electrons. So you got to know how many valence electrons there are. So how can you use this thing right here to do a real quick shortcut to figure out how many valence electrons we can draw? You count the group number. So we don't use the atomic number because that's the total protons, which will equal the total electrons. Valence are the ones in the outermost energy level. So those orbitals at the outermost energy level are the ones that will interact. And if 2 atoms have orbitals that overlap and electrons equally are shared or unequally are shared, but kind of equally at least, you form covalent bonds. And so how many valence electrons does carbon have? 4. Every atom of carbon has 4 valence electrons. How about oxygen? 6. So we have 1 carbon atom that has 4 valence electrons. And we have 2 oxygens that we're going to draw. And so that will be 6 valence electrons plus another 6 valence electrons, for a total of 16 valence electrons. So that's how many electrons we draw. And in a covalent structure, we draw them as either dots or we use a bond as a line. And so in order to start putting bonds and dots, we have to put symbols. And we're going to draw 1 carbon symbol and 2 oxygen symbols. So we got to put them down on paper. So how do we put them on paper? What goes where? The C's in the middle because carbon likes to make a lot of bonds. So if you have more than 2 atoms, at least one thing has to be in between. And we're going to start with reviewing how to draw simple molecules, and then we're going to go to more complex after we do the simple. Complex just means that you have several atoms and then several things around those atoms. Okay, so we got 2 oxygens. And then we put the electrons in a systematic way as bonds and dots. And I gave you some overriding, like, do this with these really common elements. So does anybody remember what I told you about oxygen? How many bonds does oxygen like to form? 2. And how many dots? 4. So the guidelines that I gave you were, if you're drawing something simple like this, start with 1 outer atom and draw it like it wants to be drawn. And then you go to the other outer atom. So what would I do with this other outer oxygen? We do the same thing. 2 bonds, 4 dots. Then you count how many electrons. And every line is 2 electrons, and then there's a pair. So you count by 2. So 2, 4, 6, 8, 10, 12, 14, 16. So I have used up 16 electrons. How many are left over to go on carbon? 0, which is good because carbon does not like lone pairs. Okay, so there it is. There's a drawing. What you just drew was a simple covalent molecule. So the reason it's simple is because there's just a few atoms, and because there's more than 2, there was only one thing in the middle, the rest of them were around it. More complex would be if you had a long chain or if the atoms formed a ring. And we're going to do those, but we're not going to do it in a really complicated aspect. I'm going to give you like the skeleton. And then you just use rules like hydrogen forms 1 covalent bond and carbon forms 4. You're going to use rules like that. We'll do those together in class probably next Tuesday. But I want to be sure that you understand certain terms. And so the word molecule is often misused outside of a chemistry class. And even in an introduction to physical science kind of class, it's often misused. Molecule is not a synonym of the word compound. Molecule has its own definition. And if we use like logic and discrete statements, we would say not all compounds are molecules and not all molecules are compounds. So what does it have to be a molecule? There are 3 things that have to be true to be a molecule. And there are a lot of molecules out there. So this is not some kind of rare thing that happens. Okay. To be a molecule, there has to be 2 or more atoms. What I mean by that is there can't be 1. Why does there need to be 2 or more? Because there has to be a covalent bond. So that eliminates ionic, metallic. They're not molecules. Okay. And lastly, there needs to be a defined, or you can use the word definite, number of atoms. Okay. 2 or more atoms covalently bonded. And when you look at a formula or a structure, and structure means that the bonds are already there, the atoms are already laid out, that when you look at a formula, that is the number of atoms there are. Or if you look at a structure, which is the covalent bonds, that is how many atoms there are. So what this means up here, 2 or more atoms, it's not monoatomic. It's not just one symbol. Okay? They have to be something that has covalent bonds. And if you see a structure or you see a formula, that's the number of atoms there are. Okay. So not everything is a molecule. So let me see, I've got. So like right here, I'm going to give y'all, I need to make 1 more copy because I only have 8 copies. What I mean by structure is something like this. You see how there's already bonds there? The dots are not on there, but this is not simple. I mean, it is kind of simple because it's just glucose. That's all it is. But it's not the formula of glucose, it's the structure. So it's showing you the bonds, it's showing you the individual atoms, and you see there's covalent bonds between them. And the number of atoms you see, that's what it is. Or you see a structure that has understood atoms. This is not some geometric figures. These are understood to have carbons. We're going to talk about that, about how you look at that and you don't see them as 2 hexagons, but they're rings of carbon with hydrogens bonded to it. But you see those lines? Guess what those lines represent? They represent covalent bonds. Every line represents a covalent bond. It's just all the bonds are not drawn. When you see a formula, you cannot automatically assume the kind of bonds. You have to look at the identity of the substances. Okay, so on Thursday, what we're going to look at, when we look at covalent here, I want you to think back to these kinds of bonds. I'm going to give you a summary on Thursday. This summary is on Moodle. It's not hidden. It's like, here's the study guide for the section. The very opening part of it is, hey, look at these bonds. Okay, so the kind of bonds that exist, covalent bonds. Anybody know any other kind of bonds? Ionic. Metallic. And no bonds. A substance, which is you have a formula, you have a name, whatever. It can fall into these categories. The atoms can be bonded by covalent bonds. The ions can be bonded by ionic bonds. The metals would be bonded by metallic bonds, or there's no bonds at all.